Here we're just taking a look at combinations of functions, and we're basically going to think about this as each one of these as separate integrals. So in letter A, now you don't really have to do this, but I will go ahead and write the integration term by term. That way I can split this up into smaller, more manageable problems, and I'm going to factor out any constants where applicable. I guess I didn't do it over here. I could have pulled the 4 out. But this one's a little bit easier to integrate without factoring it. So you can go either way. 1.4 to the x dx. So this guy is going to be, this is a power function, so we're going to add 1 to the exponent, divide the coefficient by the new exponent, minus, well, I'm going to factor out a 2 here because I see that this looks like a natural log, so minus 2 times the natural log of x, plus, now this is an exponential function, and so I'm going to basically do my 1.4 to the x over the natural log of 1.4, and I'll add by arbitrary constant. So in letter B, we're going to do the same thing. We'll just throw the integral all the way through and treat these term by term, and plus one more term, so the integral of 5 to the x dx. And so we'll factor stuff out. I guess you could do that as you begin. So this is basically 2/3 times 1 to the x dx. I don't really have anything to factor out here, so I won't rewrite the whole line. But so this will be 2/3 natural log of the absolute value of x, minus, I know this is going to be x to the 7th, and I'm going to divide the coefficient of 1 that we could technically write there by the new exponent, plus this is an exponential function, so we have 5 to the x over the natural log of 5 plus our arbitrary constant. Finally, in letter C, and I'll try to squeeze that in up here, we have x to the negative 2 plus x to the negative 1 minus x to the 7 minus 1 over 2 to the negative x. Now, this is not obvious at first, but we got to be careful here, because you might say, well, this is a power function, and I'll just go ahead and add 1 to the exponent, and then I'll go ahead and divide by 1. Well, so what I'm implying here is, let me kind of break these up term by term. Plus the integral of x to the negative 1 dx minus the integral of x to the 7 dx minus the integral of 1 over 2 to the negative x dx. Okay, so this guy I can do just fine, but here notice that if I add 1 to the exponent, so I'll work over here. If I add 1 to the exponent, and I then take the coefficient and I divide by that new exponent, what negative 1 plus 1 is 0. Okay, well, so that just means I take the coefficient and divide by 0, right? Well, that's a problem. We can't divide by 0. So you end up with an undefined term. So does that mean this guy has no original function associated with it? That there's nothing that you can take the derivative of to get x to the negative 1? Well, here's what we'll do. We'll go ahead and rewrite that term without the negative exponent. So what I'm proposing is, remember what we do is, if it's a negative exponent, we think about it as over 1. If you want to think about it as flipping the exponent, changing the sign of the power, well, look at that. X to the negative 1 is just another way of saying 1 over x. And we actually know that the function whose derivative is 1 over x is the natural log. So we'll do the same thing here. And now it's tempting to think that, oh, 1 over 2 to the negative x, that's also a natural log. Well, that doesn't look like this. This is 1 over x. This is 1 over an exponential. So I'll also do the same thing here. I'll flip it so that it's not 1 over 2 to the negative x, but so that it's 2 to the positive x over 1. So all I'm doing is just a little bit of trickery here, just to get it to look better, to look more like things that we know. And so now I can integrate term by term. So here I don't have a problem, because if I add 1 to the exponent, now be careful, adding 1 makes it less negative, and then I divide by the new exponent, I get 1 over negative 1, x to the negative first. And that's okay. No undefineds there. Plus the natural log of the absolute value of x, minus, add 1 to the exponent, this is a power function, divide by that new exponent, minus, well, this is an exponential function, so this is going to be 2 to the x over the natural log of 2, add our arbitrary constant, and we're done.